Hi DAIS kids, welcome to Doubt Shout. To continue with our series of most likely questions for your upcoming international maths exam. Today we are going to solve a 9-marker questions from May-June 2022, and it belongs to one of the most difficult topic called transformation. You can see the question on my screen. The first question here is that we have to enlarge the triangle A with a center 4, 3 and a scale factor is 3. So we go to the center 4, 3. We go to this point 4, 3, and from there we connect one of the point on the triangle. Let me connect the most simplest point to be this one. Now from here we have to enlarge this figure by scale factor 3. So I'm going to multiply this particular length by 3 units and continue in the same direction. I reach here. The other way to look on enlargement is 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 that the length of the triangle gets actually multiplied by 3. So the length right here is 2 units. This length has to become 6 units. But we also know that this one of the point on the triangle has now shifted here. So from here I can just make 6 units, 2, 3, 4, 5, 6 units. And then this length, which is of 1 unit, is going to become of 3 units. So 3 units in this direction. And finally, I'm going to connect this point. This will be the enlarged figure A dash, call it to be A dash, which has a center of enlargement at 4, 3. That answers your first part of the question. Part B, describe fully a single transformation that maps the triangle A onto the triangle B. Now, if you look at the triangle A here, and the triangle B, they have not changed at all. In fact, I can just displace the triangle A onto triangle B, and whenever the displacement comes into picture, it is basically a simple translation. The translation seems to be that the triangle has moved some unit to the left and some units up. Let me take this particular point. It has moved 1, 2, 3, 4, 5 units to the left and then going up by 2 units. So I would say that there is a translation. There's a translation vector which is moving 6 to the left. 1, 2, 3, 4, 5. Sorry, 5 to the left and 2 units up. Going back to the same question, second part, we have to map the triangle A to the triangle C. Now A to C seems to be like an enlargement, but they are not enlargement because we can see that they have some horizontal line which is acting as a invariant line. But what is that horizontal line? That also has to be identified. So whenever you see an enlargement where the x values has not changed, that means some y value is definitely going to act as the invariant line. Now to identify that, we would attach one of the point on the original figure to one of the point which has been already transformed. It seems to be like in stretch, so we got to find out the stretch factor. For that, we need to identify from where the stretch has been started. So if we go a little up where the original figure is, if we go a little up, let's say the invariant line is going to be at y equal to 3. And if I check it from this particular line, the original figure is 1 unit away. And your transformed figure is 3 units away. The very first point I meant. So the scale factor or the stretch factor will be 3 upon 1 unit, which is going to be 3. Let's see if that is true for the other points also. If I look at this point, where the original point of this corresponding point on the original figure is going to be this, which is 2 units away from the invariant line. Now it is actually 1, 2, 3, 4, 5 units away from the invariant line to the transformed figure. So if we do 5 upon 2, we get a different stretch factor. So y equal to 3 is actually not the invariant line. So we move it a little bit up. Let's go to 4, and then we try to repeat the same procedure. Now from this particular line, which is at y equal to 4, if I see that this is 2 units, and from here this is 4 units, so the stretch factor has to be 4 upon 2, which is going to be 2. If I look at the same thing from the other side, this much distance is 2 units, while from the same invariant line, the same corresponding line is 4 units away. So 4 upon 2 is going to be 2. That is matching with our previous stretch factor. Look at one more point. Let me take it from the invariant line to one of the point on the triangle, which is 3 units away, and the corresponding point has moved to 6 units away from the invariant line. This is the corresponding point. We see that 6 upon 3 is going to be 2. So the stretch factor is of 2 units, with the invariant line to be y equals to 4. So A can be mapped to triangle C by a stretch scale factor 2 with the invariant line to be at y equals to 4. Done. Let me erase this part. Now the next part of the question is that a triangle A can be mapped onto the triangle D. So we are trying to map A to D, which seems to be like a rotation, but let's read the problem. The triangle A can be mapped to triangle D by a rotation of 90 degree clockwise, that's correct, about a point on the line x plus y equal to 9, followed by a reflection. Alright, so there are two transformations here, that any point on this particular line, this line is x plus y equal to 9. You got to pick up any point on this line. Then you have to rotate this triangle about that particular point by 90 degree and see where do you land. And once you are landing to a particular triangle, from there you have to see that, suppose that you have landed here, from here you got to see that how can you reflect this particular triangle to D by a reflection. Alright, so let's just take any random point on x plus y equal to 9 and let's follow the rule of rotation. Let's say I'm here on a point where x plus y is equal to 9. So this point is at 6, 3. Now, if I attach any point from this point to the triangle, let's say I have taken this point, I need to rotate this figure by 90 degree. To do so, I need to see that this particular point is 1, 2, 3 units to the left and 1 unit down. 3 units to the left and 1 unit down. When we do a 90 degree rotation, and that too clockwise, we interchange -3 -1 to -1 -3, and actually we make this particular coordinate, the y coordinate, to be negative. It's already negative, so we have to make it positive. The rule is very simple. We make x comma y to y comma minus x. So if we follow that, from this particular point now, we have to move 1 to the left and 3 units up. So if I go 1 to the left and 3 units up, 1 to the left and 3 units up, I will land here at this particular point. So this point has to be actually reflected here. And accordingly, you could see that this point will be reflected here and this point will be reflected somewhere here. So I'm going to have a rotation. After the rotation, I'm going to get a triangle like this, something like this. But this triangle is not directly mapping to the required triangle D. I could see that this is exactly a mirror image about a line in the middle. So that line in the middle will be between 4 and 5. Let's call it to be 4 plus 5 divided by 2, x equals to 4.5. So once I reflect this purple figure about this line, I'm going to get back to this figure, which is the original figure D, and that was required. So what we have done here, that we have actually taken a point 6 comma 3. From there, we have rotated the figure by 90-degree clockwise, and then we are reflecting that figure, the one which is rotated, we are reflecting that along a vertical line which is at x equals to 4.5. But there can be many possible solutions because they are only asking about one possible center which is there on this line. Suppose anybody is taking a different center, different point on the line. Let's say somebody is taking this point on the line for this center, you're going to get a different rotational figure. The rotational figure will be now, which is 2 to the left, 2 down. Now you have to go 2 to the left only, but 2 up. So you will end up 2 to the left and 2 up. You will end up getting a point here. And from here, you will be making another triangle, which will be a rotated one. So you might see a rotation by 90-degree clockwise. A will be mapping to this intermediate figure. Now, a person who has taken a point 5 comma 4, for this guy, the reflection line has to be one in the middle here, which is between 3 and 4. That will be x equal to 3.5. So somebody is taking the point center, the center point to be at 5 comma 4, and the reflection line to be x equal to 3.5. That could be also one possible solution. So that is it. I hope I was able to explain you this entire question. Also, I'm gonna put this PDF in the description section so you can have a look there. And please note, guys, that we have a free live doubt solving session on 30th October, which is this Sunday. I will be covering 1 hour crash course on logarithm, and I'll be happy to take all your doubts on logarithms only. So do check the description box for more details. Also, do hit the like button. Do subscribe if this video was helpful to you. Do put your doubts in the comment section, and we promise that we will address each of those doubts. See you on the other side. Thank you so much.